Hello and welcome to 360 DigiTMG. You know that DigiTMG stands for Digital Transformation, M for Management, and G for Governance. We believe that there is a wave of digital transformation going on, and we also believe that we have to embark on new things which are going to shape the world. And we also need to manage the data and govern the data throughout. And we at 360 DigiTMG have come up with domain analytics programs. We have life sciences and healthcare analytics. We have financial analytics, marketing analytics, HR analytics, supply chain, cybersecurity, and the list would go on, right? And we have 50 plus programs that we are planning to launch. That's in a nutshell on what we intend to do, right, as part of this new firm. Okay, today's session would be very different. It will be extremely different in the sense we will be going to 36,000 feet high, and we will be having a high level view of our project management methodology, which is used to drive data science, data mining, machine learning, and artificial intelligence kind of projects. Over the few years, there have been a lot of effort in terms of standardizing the methodologies and defining the best practices which are followed, right? In doing what? In building your data science solutions and data science projects. So we will understand about the various project management methodologies, frameworks which are used for building data mining solutions. We'll then look into KDD, knowledge discovery databases, cross-industry standard, cross-industrial, CR is for cross, I for industrial, standard processes for data mining. We'll look at SEMMA, which is sample, explore, modify, model, and assess, right? We'll discuss about these. So since our 1980s, the field of machine learning has emerged significantly. And with that, people have put in a lot of effort to come up with a few process frameworks, which are going to guide us and which will help us perform our data science activities, tasks, in such a way that success is more or less guaranteed. And these are the three main models which people usually follow. These are also called as process frameworks or methodologies, right? Then we will look at our unique methodology, which almost always works. We have looked into a lot of best practices from these three models, and we have used our domain knowledge. I mean, for the past 15 years or so, we have been extensively working in this area, and we have put together all of our knowledge, right, for you guys. And then we will deep dive into each and every stage of our unique methodology. But I have to upfront tell you that our unique methodology is very close to crisp DM, right? So let's get started. So these are the three project management methodologies or process frameworks, whatever you want to call that. Of course, framework is different from methodology. People from quality background might want to counter that, but that's fine. These are all thinly defined. KDD, crisp DM, SEMMA. Let's deep dive into each one of these. And even before I deep dive, let us understand about what is this data, what do you mean by information, what do we mean by knowledge, and what do we mean by wisdom. This is called as DIKW pyramid. Okay, so let's understand this. Basically the risk, if you were to take a decision based on data is very high. If you see here, red, very high. And the risk, when you actually take your decisions based on wisdom, is extremely low. You would be in the green zone. So how do we transition from data to wisdom is something which actually makes sense uh, to determine the success of your projects. First, you will have the data in the most raw format possible. Alongside explaining, let me also give you an example. Right? Say you have messages, SMS data that you have. Okay, so you collect the data. Okay, as part of data and drawing information from the data, what do? We collect the data, we pre-process the data, we disseminate the data, we store the data, we display to the customers, and we protect the data. Data protection is extremely important. Okay, and then these two, data and information, will tell you what has been happening until now. So data in the most raw format can be considered as SMS data. What would you do with that? You try to process that data and you try to get some information out of that. For example, information could be there are 100,000 telecom customers. Okay, they are all in the age group of say 20 years to 45 years. Okay, and probably another insight could be 60% of them use internet service in the evening from 6 p.m. to 11 p.m. These are all the insights that we are trying to draw from the data. Okay, based on this insight, you would move to the next step, which is knowledge. And this knowledge step will tell you how. Until now, you were able to answer questions pertaining to what is happening in this data, right? Which age group are you using? How many customers are there, right? So just the what part, what is there in the data is addressed as part of information. Then you move to knowledge. Knowledge will answer questions such as, all this is fine, but how do you think old age people, let me write it down here, how do you think old age people are using this SMS service? How are they using, right? This is knowledge, right? To go to one step further and try to understand how. And then you have wisdom. Wisdom is the highest stage that one can attain, and wisdom is all about implementing the answers to the knowledge step, and it also answers why. 60% of the people use the internet service in between 6 p.m. to 11 p.m. Why? Right? That why part is wisdom, right? So this is how you transition. When you have the data, it is in its most raw format. From data, you get the information that would take care of what part. Then you move to the knowledge part by answering how is it happening, and then why is it happening, right? This is how we transition, and this is exactly what your data science is all about, right? You move from data to information to knowledge to wisdom. Okay, let us understand about KDD. What is KDD? KDD stands for Knowledge Discovery Databases. It was presented way back in the year 1996. Okay, and people started integrating your data warehouse, machine learning, you have operations research, data visualization, parallel computing, all of these. People started integrating all these systems. And that is when uh, people thought that, okay, let us think about a framework around that, right? A person by name Fayed in the year 1996 has come up with this, right? uh, KDD center databases, right? Knowledge discovery databases center around the overall process of knowledge discovery from data that covers the entire life cycle of data, which includes how are we going to store the data? These are the 5 stages, right? How are we going to assess the data, right? How algorithms can be scaled to enormous data sets, how the results can be interpreted and visualized. These are the various phases. The first step is selection, right? The selection and integration of the data from various sources. So you might have data in the form of PDF, you might have data in your Oracle database, you might have data coming in from IoT sensors in form of logs, you might have some data in Excel format, whatever be it, right? The point is you have data coming from various sources. In the step which is selection, we integrate the entire data coming from many possible different sources. And when you have data coming from various sources, it is called as what data? Heterogeneous data, right? You have heterogeneous data sources for that case. Selecting only those variables or sample of data which is relevant for your analysis, which is relevant only for your analysis, right? That is called as selection. So you have all this data. You might not need all the data for your analysis that you're trying to perform, the business problem that you're trying to solve. So you first collect that data, and it is even more important because uh, of all the regulatory norms, right? European Union GDPR, General Data Protection Regulation norms. You should not be having, as an analytics firm or any firm for that case, you should not be having the data more than what is required for you to perform your analysis. And the penalties are very severe. If you breach any of the norms, then it's $20 million penalty or 4% of your global revenue. That's very huge impact, right? This would simply mean that startups and the tier 2, tier 3 companies would just shut down, right? So this is a pretty simple step. You have a lot of data. You select only that data which is relevant for you. Once you have the data, your data won't be clean. It will be noisy, right? You'll have errors, outliers, you'll have missing values. There'll be a lot of discrepancies. You'll have to deal with those discrepancies. So the unclean data that you have would give you invalid output. Garbage in, garbage out. So performing complex analysis and data mining activities requires one to spend a huge amount of time in pre-processing the data and cleaning the data, right? So you collect the required data, you treat your outliers, you apply your domain knowledge and remove that data which you feel is irrelevant, remove the duplicates, inconsistencies, right? Decide upon what technique do I need to apply to impute the data, that is handling the missing data and all that, right? Then you move on to the next step, which is transformation. Data is transformed and presented in a way that your data mining can be performed smoothly. So finding the useful features. So let me write down a bit here. So in pre-processing, you probably deal with outliers. Not probably, you deal with outliers. Okay, and then you apply your domain knowledge and remove irrelevant stuff. Do require changes. Some amount of feature engineering is done here, and then you handle your missing values. There are many. There are many things, right? We will discuss as and how we progress ahead, right? Transformation. Transformation is all about getting the useful features which are required for an analysis. When you have high dimensional data, a lot of attributes, a lot of variables, then you might want to reduce the dimensionality. You apply dimensionality reduction techniques, a few of the transformation techniques to ensure that all the variables are of same type. And there are a lot of transformations. I'll list down a few of these, but of course we'll discuss these as we proceed further. You might want to smoothen your data. Do you know what do I mean by this? Smoothing your data. If you have continuous data, you'll discretize it. You'll create bins. You might want to perform clustering, get clusters, homogeneous data, right? All these. Aggregation, data aggregation. What do you mean by that? If you have daily data, maybe you might want to add them up to get monthly data or weekly data, right? And then normalization, standardization, feature construction. What do we mean by feature construction? Feature construction is dimensionality reduction in some sense, right? So PCA, SVD, there's something called as MDS. All these are the techniques used, right? And then all these techniques will help transform your data so that you provide the right data to your data mining algorithms. And here in data mining, you explore the data. You perform exploratory data analysis. You perform graphical techniques, etc. You build predictive models, classification models, or prediction problems, right? Or probably you'll now do better clustering, so on and so forth. Finally, after that, you interpret and evaluate your results. Okay, so whatever patterns, models that you have built, you're going to evaluate that based on some accuracy measures. We will get into all these. This is just KDD, right? In a nutshell. Do not press the panic button yet, right? We will certainly in finer detail discuss about all these steps, right? Then you have something called as SEMMA. SEMMA stands for sample, explore, modify, model, and assess. It is nothing but collection of sequential steps to build your machine learning models, and this was incorporated into SAS EM, E-Miner, right? That's a product from SAS Institute. And SAS, is one of the largest producers of commercial statistical and business intelligence software. Okay, but R and Python stands out from the rest, right? Having said this, their model that they have come up with or the framework that they have come up with, yep, that's good. But these tools, commercial tools, by no means can compete with open source technologies, right? Okay, there are 5 steps. 1, sample. What do you mean by that? You select a subset of data of the right volume of data. Okay, from a large data set. Why am I saying right volume? When I say subset of data does not mean you'll just pick up 100 rows or 200 rows, right? It should be a good representation of your population. Okay, you also have to bear in mind the computation power that you have. How much is your server configuration, right? How much data can you take without impacting the performance? All these come into picture at this step. And at this step itself, you divide the data into training and test. Training and testing and validation. We'll discuss all these things. What do we mean by training, testing, and validation? What do you mean by validation data? Right. Next step is exploration. In this step, we try to understand the data and the relationship among the various variables. So you just try to understand the data and look at the relationship among the various variables. Okay, and you perform something called as univariate analysis, one variable analysis, bivariate analysis, two variable analysis, and multivariate analysis, which is multiple variables are analyzed at one go, or however you want to analyze. Right? You look at the distribution of the data, right? When it comes to univariate, bivariate, you look at the relationship between two variables. And when it comes to multivariate, you look at the relationship between multiple variables. You also do data visualization here. Data viz. Right. And then you move on to the next step, which is modifying the data. In this modify phase, data variables are cleansed. Okay, you clean the data. Then you derive new features. You perform feature engineering. You apply some business logic. You try to get new data. We will discuss all these, friends. I mean, feature engineering, univariate, bivariate, multivariate. We will discuss as and how we proceed further. And the output that you expect from modify phase is a clean data set, which can be given to the next phase, which is all about building your model. We apply data mining techniques on the pre-processed data, right? So, and then we try to measure the performance of the model. That's the assess phase. Here, the model performance is evaluated against the test data, right? And you look at whether results are reliable and whether they are useful for business or not. One thing, you might get 99% accuracy at the end of the day. If it is useless for business, doesn't help, right? Model, I mean, of course, you know a lot about models, predictive models, classification models, unsupervised learning models, and all that. So we'll anyways discuss about these further. And then my favorite, right? Undoubtedly, I mean, this is something that I like the most. CRISP DM, cross industry standard process for data mining, or cross industrial standard process for data mining, however you want to call that. This was established by European Strategic Program on Research in Information Technology. That was an initiative which was aimed to create an unbiased methodology that is not dependent on any domain. This is domain agnostic. Do financial analytics or retail analytics or automotive analytics or aviation analytics, doesn't matter. It is domain independent. And people came up with this in the year 1996. That was when this idea was conceived. 1996. Wow, right? And it was first published in the year 1999. Okay, while I was in my school. And then it was reported as the leading methodology in 3 years: 2002, 2004, and 2007. Right? They thought they will update it again, but then they became inactive. I'm not sure why they have become inactive, but it really makes sense to proceed further. Maybe it has 6-step iterative process, iterative, hence you see that: business understanding, data understanding, data preparation, modeling, and then you have evaluation and deployment. Yep, you have evaluation and deployment, and this process would continue on and on. We will be let's quickly look at the quick comparison between these three, and then I think we are good to move and discuss about our unique methodology, which is very closely aligned with CRISP-DM. Okay, here KDD is the oldest of these three frameworks. CRISP-DM and SEMMA are more practical in terms of implementation in comparison to KDD process. And if you want a lot of iteration, which is very important in the space of data mining, then CRISP-DM is more complete because it has a lot of that iterative flow. And then it covers all areas of building a reliable machine learning system. SEMMA, it has sample stage. It's important that you have a very good understanding about all aspects of business to ensure that the data that you take, the sample data, has the maximum information, or it can give you maximum information. Right? And then, but off late, there has been a drastic drop in the amount of data, right? And the computational power has exploded. Hence, it doesn't really make sense. I mean, almost, the logic of sample is gone. If you have population, please work on population. The concept of sampling has come into picture when the real world data was so large that you could not store that or you could not process that. Okay. Of course, while there are differences, I feel that there are a lot of similarities, right? In all of these three models. Okay, now let's get into CRISP-DM, one of the most popular process model, which has been tried and tested for years together, and it has been giving exceptional results. In all of the projects that we perform, we to a great extent use this methodology, right? It gives you a structure, it gives you a logical flow. Okay, and the first step of your CRISP-DM is business understanding, right? This is the first step. So we'll understand about business understanding first. Let's do a deep dive into each of those 6 steps, starting from business understanding. Within business understanding, the first step is defining the business problem. That is very important. Define your business problem. This business understanding is going to kickstart your project. This is the initial phase, which you cannot at any cost avoid. This is the, if you ask me, single most important phase of the entire life cycle of projects. And the main object here is to understand the business context. What is the problem that we are trying to solve? Defining the business requirements and converting the business problem into your data mining problem. So you'll have the business problem. How do we convert this business problem into analytical problem? Right? This is extremely important. And what are we expecting here? We are going to set expectations on what is it that we are going to give you. Customer would come to you with a business problem. What are you going to give to the customer? So you're going to set the expectations. If customer says, hey, I want 100% accuracy, you would say 100% accuracy is not possible. We might give you 98 or 95 or anywhere between 95 to 98. You define such expectations. You also define the success criteria. When can you claim that your project is a success? Okay, this is from two perspectives. One is from the customer perspective, another is from your own solution development team perspective, which includes your data scientists. Solution development team, which also includes your data scientists, right? And the final deliverable of this business understanding phase of CRISP DM is to have detailed plan. Detailed plan with the timelines, uh, cost details, success criteria, right? Assumptions, if you have any assumptions. I'm assuming that the customer will give me complete data. I'm assuming that customer has a cloud environment to which we will have access to. I'm assuming that customer has a server on which we have to perform data mining. All assumptions, constraints. Customer is in Africa, remotely connecting from India to Africa would mean a lot of internet glitches. Constraint. What are the challenges? What are the caveats to proceed further is something that you record as part of this. Within this business understanding, you have 4 sub-modules. The first thing is defining the business problem. In defining the business problem, you try to come up with business objectives of the problem that you're trying to solve. So the first step is come up with business objectives. Okay, that's the first step. And you have to build a formal definition of your problem. So get the business context of the problem to be solved. Assess the problem. Take help of domain experts. Take help of subject matter experts, but try to understand in very finer detail. And also, there might be multiple points that might come out of the discussions. You have to come up with the key points, key pain points, which you need to address. Or what areas are you trying to solve this problem? Are you solving this problem for entire organization, or are you trying to solve this problem for only supply chain department? Too many employees are resigning. Okay, you're solving the problem only for HR department. Right? And then you don't stop here. Friends, you do not stop here. You also do a market research to understand what kind of solutions already exist. Okay, you do a market research to understand what solutions already exist. Okay, in those solutions which are already available, what is lacking? Okay, already you will have solutions. What is lacking in those solutions? And what needs to be improved? Take that. Do not reinvent the wheel. Majority of the problems are solved. If they are not solved problems, they would be part of research projects. Okay, so do this. And then when you define the business objective, there should be clear deliverables. What deliverables would be coming out of your project? What will be the success criteria? Okay, so here when you work on this, not just data scientists, not just chief data officers, but your business folks, domain experts, analysts, subject matter experts, everyone should be involved. Here are a few examples, very good examples though. Okay, first, say there is a banking problem. Your customer comes to you and says, significant proportion of customers who take loan are unable to repay. A lot of customers are taking loan, they are unable to repay. That's a problem. How do you solve it? For this problem, first you need to come up with business objective and business constraints. Business objective is minimize the loan defaulters, right? Because many people are defaulting on the loan, minimize them. That's the objective, makes sense. But do you know what you say? Built a prediction model which says there is 90% probability that someone will default on the loan. The moment you hear this, that hey, there is 90% probability that a person will default on the loan, then you know for a fact that you need to reject the loan. If you keep rejecting the loan based on, sorry, this probability, based on probability values, then what will happen to bank? Bank will get into losses. Why is that so? Or they will not make profits. Their profits will shrink. Why? Because until and unless you approve a loan, until and unless you lend loan, you would not get interest. If you do not get the interest money, then you cannot, run your business. So your business constraint is very important. Your customers would usually levy on you. They will not directly tell you, but you'll have to understand and record it, right? Based on your discussion with the business folks. They would say, maximize my profits. That's a constraint. Do you know how to solve this? You can simply say, alongside just predicting on whether a person will default or not default, you might want to say that I will also give you survival analytics. And I'm going to tell you that this person 1 has 90% probability of defaulting on the loan, but this person will default after 28 months. Wow, such an amazing insight. As opposed to just rejecting, what I would want to do now is, because I need to maximize profits, I will still lend a loan, but I will reduce the loan tenure from to probably 24 months. I will lend the loan still for 24 months for a slightly higher interest rate, and I'll lend less amount than what this person is eligible for. So that way, I'm still making profits. This is how you need to list down. And there's a nice video that we have come up with. We are, by the way, coming up with cartoon characters. Okay, like comic series, right? Let me play this. I also want to see what your reaction would be for that. Oh, okay. Let me do one thing. Quickly, I would play that. Okay, so let me play this video. We are trying to come up with comic series. So it's not playing. Yep, I could figure out this. Just listen to this. Right, so we are trying to come up with a lot of such animated videos to explain the various concepts of data science, so that understanding becomes very easy and very simple, right? It should not just be slides driven. It should also have such animated videos. That's the underlying, concept. Anyways, let's proceed further. Let us understand a few more business problems. Significant proportion of customers are complaining that they did not do the credit card transaction, right? So a significant proportion of people are saying that they have not done the credit card transaction. Someone else has done the transaction. So for this, the business problem would be minimize the fraud. Obviously, it goes without saying, you try to minimize the fraud. That is the business objective. And when it comes to business constraint, you want to maximize the convenience. Why? How do you minimize fraud? Usually people minimize fraud by having double layered security, triple layered security, too many one time passwords coming your way, right? That will cause a lot of inconvenience. So you're saying that while you try to minimize the credit card fraud, can you also maximize the convenience cost to the customers, right? Yet another way to minimize the fraud is the moment you do any transaction, customer service person would call you and check with you. Hey, did you do the transaction? If they keep calling you on each and every transaction to check whether you have done the transaction or not, you would be unhappy. You would say, hey, what the heck? Why are you calling me so many times? That would cause inconvenience. Hence, whenever you try to solve a problem, business constraint is as important as business objective. And when you list down business objectives and constraints, please bear in mind that you might want to use the words minimize, maximize to the extent possible, right? Or any of your data optimization terms which are widely used. And try to ensure that you have your business problem listed down in 2 words or 3 words max, 2 to 3 words. It should not be bigger than this. It should not be sentences long, right? Business objectives are constraints. They have to be rightfully documented. And there will be, I'll play another video. And then after playing another video, I would certainly, not play any more videos, friends. So do not worry too much from that perspective. So I'll be playing that video in a bit from now. So I need to show you guys this video. One second. I think there is no audio to this, so I need to.
So let's watch this video. So this is how
Yeah. So this is how you need to record your business problems, and that's a very good animated video to help people, even a layperson, understand on what kind of problem that we are trying to solve. Just some kind of a comic series is what we are planning. Okay, business problem C. Say the yield of crop is not improving year on year, some agriculture related problem. For this problem, your business objective would be maximize the yield, amount of yield that we have, right? And while you try to maximize the yield, your businesses will also put constraints on you. And that constraint is minimize the cost. Because in order to maximize the yield, you might say, okay, let me fly drones on top of the crop and let me identify or capture data such as intra-plant distance. If you have plant here, how far is each plant from the other plants, intra-plant distance, right? And various things is what you can capture basically. If you have contour sensors up to an inch, you can determine the leveling of the soil. Your soil won't be even like this, right? In agriculture fields, it'll be uneven. So where should you sprinkle the water more? Where water clogging happens? So all this analysis can be done. And also, if you have multispectral cameras attached to drones, right? Multispectral cameras would mean, right? This is assumed drone. I ignored my drawing. So multispectral cameras would mean cameras which will capture not just the visible spectrum, but which also will capture invisible spectrum, the ultraviolet and infrared regions, right? Which we cannot see as humans. So what happens is if you have all these plants, right, then when you fly your drone, and if you have weeds, insects, it is going to reflect a different color on the image. You'll get a heat map. It will reflect a different color altogether. Okay, it might be reflecting a red patch saying that, hey, weeds have started here. Weeds normally do not start throughout the crop overnight. In some portion it starts. So if you monitor using your heat map images, you can do image processing. And nowadays people are also having sprinklers, pesticide sprinklers. So those sprinklers will automatically sprinkle. The moment it identifies or detects a weed real time, it will sprinkle the pesticide, right? And it is very important, you know what, if you sprinkle more pesticide than what is needed, then what happens is usually after one crop for 6 months, you probably want to start another crop. Say one crop is for 6 months. In the next 6 months, the residual deposits of pesticide or chemicals would impact the yield. So all these are very important when you are working in the space of agriculture. Agriculture analytics is, wow, very, very important, right? So you might want to maximize the yield. But when you go to a farmer and say, hey, purchase a drone, fly it on top of your crop, it will capture all the statistics, and then you can sprinkle the, pesticide. They would obviously say, oh, come on, I cannot invest on this. It's a lot of investment, capital investment. So your solution, whatever you're trying to propose, should be low in cost, right? So while you maximize the yield, also try to minimize the cost of the solution maybe that you're trying to implement. So defining business problem, business objectives and constraints is extremely important, and it would test you. It would certainly test you. And people say that the first three steps, understanding the business problem, collecting the data, and data cleansing, would consume 60 to 80% of your time. 60 to 80% of your time, you'd just be performing the first three steps, and building your models would be 20% to 30%, and some more time you spend on deploying. So building your prediction models is the most trivial part of your entire analysis, or of your entire project rather. Okay, then the next problem could be, maybe there is Amazon or Netflix or online portals such as Flipkart, Big Basket, etc. they might come to you saying that, dear data scientists or dear AI experts, my recommender system, the current recommendation system that we are using is not effective. Can you please help me? Recommendation system, it would recommend the products, right? And if you are searching for, say, iPhone XR with 16 GB or 32 GB, it would recommend iPhone XR maybe 128 GB. Recommending the same product of higher configuration is called as upselling. So you want to maximize that. What do you mean by cross selling? Okay, people who purchase, say, MacBook also purchase a connector. They also purchase external mouse and external keyboard. Wow. So what are you trying to recommend? Those products which go well with MacBook. So you're trying to cross sell. That's called as cross selling. Okay. So you do upselling and cross selling. You want to maximize that. As of now, it's not effective. But in order to maximize your recommender system, you can do one more thing. You can send emails to the customers, right? Delayed emails saying that, I believe you have searched for iPhone XR. Here are a few recommendations for you, right? Here is a coupon. If you use that, you're going to get special 10% discount. If you keep sending such coupons and such emails, it would cause fatigue. People will get bored. The moment they look at that, they are going to delete that or ignore that, right? So your businesses would obviously say, hey, while I say you maximize the cross-selling and upselling, at the same time, I want you to minimize the coupon fatigue. Now, this is an interesting problem to solve, right? Very interesting problem to solve, rather. Then you have another problem. All these business problems, the reason why we have listed down so many is because you need to have a very good handle at how to come up with business objectives and business constraints. Say organizations are resorting to digital forum to do marketing, right? Okay, a lot of marketing. Say people say that my Google AdWords that I'm doing, the strategy in itself is not effective. So what should you do? What happens usually is there is something called as impression. The moment an ad appears, that is called as impression. If an ad appears, would you click on that or not click on that? Right? If you click, it will increase your click-through rate. If it's appearing and then if you're not clicking, it would reduce. So your objective is to ensure that when you're showing an ad, you want your people to click on that. So your objective is to maximize the click-through rate. Do you know what? In order to maximize the click-through rate, you can just increase the budget. You can say, okay, for per day, I'm going to, instead of spending 10,000, I'm going to spend 20,000. So the moment you do that, what happens is your ad starts appearing on the top. In the Google search, it will start appearing on the top because you have increased the bid amount. This is common sense driven. Any person can do this, right? So your businesses would say, while you maximize the click-through rate, can you also minimize the cost per click? So with the same budget or less budget, can you still help me maximize the click-through rate? That would be an interesting proposition to solve. Okay, so very, very important. Next is, since this is clear, the next step is assess and understand scenarios. So remember, within your, let me go back just to refresh your memory. In CRISP DM, we have 6 steps, right? 1, 2, 3, 4, 5, 6. we are discussing about first, which is business understanding. Within business understanding, there are again four sub modules, and we are trying to understand about the first sub module, which is define business problem, or rather we have understood that. Now we will be moving to the next phase, which is assess and analyze the scenarios. Assess and analyze the scenarios. Right? Here we are. What is the importance of this particular phase? Let us understand. Once the business problem is clearly defined, next main task would be to analyze the current scenario. Okay, customer is facing some problem, but first try to understand the present scenario in regards to your business problem, right? You look at what is currently available with you. What kind of resources do you have? Human resources. What kind of data do you have, right? So as is state analysis with respect to what data you have, how many human resources you have, how much time will they be available for, right? What are the risks involved? All these things should be done. And by the way, risk is any uncertain event which might occur in the future. Okay, very important. I mean, I can give you one example. You know what? While we were doing consulting for Heineken beer, right? We went there to deploy servers. We assume that we have done an amazing job with respect to risk management. But then when we went there, everything was there, hardware, everything. Racks were there, server racks, but we have to put the server here in the rack, and then we had to put screws, bolts. These were missing. What big deal? But you know what? This rack was very old rack, and getting the screws and bolts there and making small change to a data center is a big deal. You have to raise a change request and get it done. We had to wait for 1 month to get this shipped because the people who were supplying these racks stopped production of those racks. These were very outdated racks, right? We had to wait for 1 month for them to actually exclusively manufacture the screws and bolts and send. That in itself was a cost. Waste of 1 month. So our organization for whom we were working had to pay penalty to Heineken for the entire 1 month of delay. They had to pay us additionally because we had to extend our stay for 1 month. Very critical. You have to be on top of that. Then we also need to look at what is required now. What key resources would be needed? What hardware do you need? Do you need GPU machine or do you need a TPU machine? What software do you need? Because you might want to remotely connect to the server and get the data. See friends, these things are very, very, very important, right? People usually have knowledge about, regular machine learning algorithms and all that. But nowadays in interviews, they are asking all these just to understand whether you have real world experience or not. Simple. They're asking 2 or 3 questions around this, job done. They'll come to know whether you have real-time knowledge or not. What hardware did you use? What software did you use? How many human resources worked in your project? These are a few things which are extremely important, right? Who do you need? Do you need a big data consultant, database administrator, IT person? Who do you need, right? That's very important. After this, you should identify for each requirement. For each requirement, you have to identify assumptions. What is it that you're assuming? And are there any constraints, limitations? And these should be recorded by doing consultation with subject matter experts or domain experts. Very important. Then you need to also verify all of these assumptions and constraints in light of the data which is available for you. Right? It depends on the problem that you're solving and the data which is available. So you evaluate these, verify these in light of data. Then perform thorough risk management. No, have no doubt on this. You have to perform risk management on the timelines. Can I meet the timelines? Do I have any risks which will not let me meet the timelines? Do I have all the human resources available? Do I have any senior resource who is about to quit? Or is there too much of dependency on someone? Don't we have backup resources, human resources? All these other risks. Data. What kind of data do we have? Are we dependent on surveys or experiments to get the data? Or do we have everything available readily? Do we have streaming data, real-time data, structured, unstructured data, which has to be combined together? Constraints. Sometimes what happens, customer would say, hey, I want you to build a simple reporting dashboard, which should get updated daily at 6 a.m. But maybe on a daily basis, your data gets processed at 7 a.m. So how can you send it at 6 a.m.? Right? It will be outdated. So you have to say that, dear customer, your point is well taken, but you have your internal dependencies. That entire data is batch processed at 7 a.m. So I can give you the report by 9 a.m. Right? You have to, right? Because it's the first step. You cannot say yes to everything to the customer, right? Then hardware and software. Do you have the required hardware? Do you have the required software? Did you place an order for hardware from US? Coronavirus shipping would get delayed. Have you thought about those things? Do you have the required budget, or are you going to run out of budget? All these are extremely important. And then you also have to build contingency plans, right? For all of these uh, risks, and you might want to counter those risks using different risk response scenarios. No one would explain this, guys. Trust me on that. Everyone is hell bent upon just thrusting the algorithms down your throat. However, it will help to some extent. But in interviews, certainly the things shifted drastically. They are looking at whether you have the real-time exposure or not, and these are a few of the things which are extremely important, right? And then you also define the success criteria. When would I say that my project is a success? Just by meeting the timelines, or just by achieving some accuracy, or after deploying the model and seeing to it that it's actually delivering the results? When? Sometimes your success criteria will be such that you implement your model, but for you to gauge whether your model is working well or not, you might have to wait for 6 months. You keep using your algorithm for 6 months, because maybe you are doing the predictions on what will happen after 6 months. So you have to wait for that 6 months duration to get over. Say you're in the month of Jan 2020, and people ask you to forecast on what will be my sales for June. Then you have to wait until June, right, to be able to see the result. So, I mean, usually what you do is you build a model, you take your consulting fee, and there is an outcome based model which happens. That means customer might say, hey, I'll pay you 60% of the amount now. Another 40% I'm going to pay you only if your prediction model gives me good results. Or in June, I'm going to look at the actual results. You forecasted the sales. In June, I'll come to know about my actual sales. If the actual sales are close to forecasted sales, then I'll release remaining 40%. Outcome based models, right? So all of these things, I mean, you have to record, you have to understand. And then document your return on investment. How are you going to gauge return on the investment that you put in? Okay, so